Hello everyone, so in this video let's talk about the singlet oxygen. Now we are going to talk about two major reactions about the singlet oxygen, right? Before going to the particular reaction mechanisms, let me give you a quick introduction about this singlet oxygen. So basically I hope that you are familiar with the normal oxygen, right? So here we have the normal oxygen molecule. As you can see, there are pi bonds here. So pi bonds and the lone pairs are also there. Now we can excite this, right? We can excite this particular oxygen into higher energy states, right? So when the oxygen molecule is excited, we call it as singlet oxygen. So this irradiation, right? So this normal oxygen to the excited oxygen, we do this in the presence of a triplet sensitizer. So let me write it: triplet sensitizer. I hope you remember about these sensitizers we have talked about in our first few videos, I guess. I will put the link here, right? I will put the link here for our playlist, so you can go through our playlist and see whether is there any particular videos that you might be interested in, right? So in this triplet sensitizer, it's very important. Now what happens is, I hope you know that there are two particular excited states. One is the singlet excited state and the triplet excited state. So in the presence of the triplet sensitizer, you have only the singlet excited state. So this is singlet excited stated oxygen molecule. So this oxygen molecule is in the singlet excited state. That's why we call it as singlet oxygen. So this is on the singlet excited state. Now, if I draw an energy diagram, right? If I draw an energy diagram, this is the normal natural ground state. This is the ground state oxygen, and when we excite it, when we irradiate it, we have the singlet oxygen, which is on the excited state. Now, our singlet oxygen has higher energy, right, compared to the ground state. So when our compound has higher energy, it getting destabilized. So this is very much destabilized. So what happens when a particular molecule getting destabilized? Like they try to get back into its stable form, right? Now in order to come back into its stable form, in order to come back into its ground state, it has to release its energy. It has to release its energy to someone. So what normally occurs to this phenomena is this singlet excited oxygen. These singlet oxygens, they are very reactive. They try to react with someone and release its energy to come back into the ground state. So that's why this singlet oxygen is very important. Compared to the normal oxygen, these singlet oxygens are very much reactive. So these are very reactive. So let's look at a few reaction types, right? And there are mechanisms to understand about this singlet oxygen. Now the first reaction. So this is called the Ene reaction. Right? This is called the Ene reaction. So let me explain to you by a simple example. So let's take a alkene like this. And here we have a hydrogen. And here we have a singlet oxygen. Here we have the singlet oxygen. Let me draw the lone pairs also. Now what happens is, this lone pair, right? This lone pair will go there and attack our hydrogen on the alkene. Due to this attack, this bond, the carbon and hydrogen bond will break, and it will go here to form a new pi bond between these two carbons. So when a new pi bond is forming, you can see this particular carbon is getting destabilized. It has to donate its electron density to someone. Now due to this electron attack, right? Due to this electron attack, you will see this oxygen has obtained a relatively positive charge, right? So it has donated its electron density. Now it's electron deficient. So this has relatively positive charge. Due to this positive charge, the electrons are pulled away from this particular oxygen. Because of that, this oxygen has now a relatively positive charge. Okay, I hope you understand the story, right? So first this attack happens. Due to this attack, this oxygen, now when the attack happens, this oxygen has to donate its electron density away. When this oxygen loses its electrons, it will pull the electron density from this oxygen. Now what happens? This oxygen has electron deficient. When this pi bond sees an electron deficient oxygen, it will go there and attack it and form a new bond between this carbon and oxygen. So our result would be, we will have a pi bond here, and here we have a one single bond, and this carbon, let me number it, 1, 2, 3 and 4. So here we have the 1, here we have the 2, and here we have the 3. Now in the third carbon, you will see here this carbon is forming a new bond between this oxygen. So this carbon is attached to an oxygen. Okay, and that oxygen, right, this oxygen is bonded to this one. So let me draw it one, and we have the hydrogen OH. Okay, so now hydrogen is attached to here, and then finally we have the fourth carbon here. So this is our ene reaction. Now in the next case, we have the cycloaddition, right? So sorry, we have the cycloaddition. So this is the reaction number 2, cycloaddition. So let me take an example again, an alkene. And let's take singlet oxygen. Now just like in this case, so here we have an attack from here, and this one will go and attack here. So we have the structure, it's like this. So we have two oxygens are bonded to our alkene. Now this is 1, 2 cycloaddition. So these are the two main reactions which we have to focus on when it comes to the singlet oxygen. So I hope it's pretty much easy. It's pretty much simple, not that much complex compared to the previous theories that we have discussed. So in our next video, we will talk about a new section, which is the pericyclic reactions, one of the important and very interesting parts in the photochemistry. So I hope you are okay with this now. If you have any problems, please feel free to comment below. I will try my best to answer these questions.